The assumed print direction of our heat exchanger is going to be in the positive z-axis, or the axes that we see here on screen. Before we move to additive manufacturing or AM designs, we should take DFAM into account, design for additive manufacturing. So in this case, bringing our attention to the bottom, right away we know that we're going to have to support the bottom of this structure. We could move forward with it, or we could work on making it self-supporting. Creo is my preferred design tool. You can see here that I've changed the bottom port and bottom section to be at about 45-degree angles to make them self-supporting during the print process. Looking at a cross section, we'll see the other parts and modifications that I did. The primary ones I want to point out are the infill volume, seen here in red, and then the inlet and outlet plenums for both the oil, here in yellow, and the fuel in blue. Let's briefly talk about the plenums. In my studies, I've found them to be a major component to successfully designing heat exchangers using TPMS or triply periodic minimal surface lattice structures. The main reason being is we want to evenly distribute the flow into the core to not only maximize the distribution and thereby increase the overall heat transfer, but also going to have a pretty significant impact on the pressure drop. For instance, imagine if we were to bring the infill volume seen here in red up to the top of this dome and down to the bottom of the hex core. When our fuel enters, it's going to hit a small cross section of that lattice structure, which we'll look at later on, have to figure out how it's going to distribute itself, and then exit a small cross section at the top. That initial entrance is going to severely impact the overall delta P, and we're not going to have as uniform a distribution as if we were to introduce plenums into the design. At this point, you might be asking yourself that the bottom half or bottom section looks a little different than the one we've printed. The reason being is sometimes, in my mind at least, it makes more sense to design some of the plenum geometry and volumes in nTopology and some of them elsewhere. So you'll see during the hex build out that we do together, we're going to add to the cold inlet plenum and the hot outlet plenum, seen here in blue and yellow respectively. The next aspect about the plenums is they generally follow the contour of our shell. So when we get to generating the shape of the shell volume, seen here in gray, not only do we need to take into account DFAM, but how we might want our flow to be distributed into the hex core. The last aspect I'll touch on in our pre-nTop prep section is defeaturing. Similar to how we might defeature parts before we move into any type of FEA, we'll want to remove any unnecessary complexities that, let's say, may impact meshing and rapid design analysis downstream. We can add those back in later.